QA worksheet 4. So question 1 says this. Ammonium chloride warmed with aqueous sodium hydroxide. So ammonium chloride is an ammonium salt. And when it's being warmed with sodium hydroxide is a base. Okay, in fact, this is also similar to the test for ammonium ion. When we want to test for ammonium ion, we use sodium hydroxide and we warm it. Because what is happening is a reaction of a base. Base plus ammonium salt will give you salt, water, and ammonia gas. So when they ask you what gas is formed, the gas is ammonia gas. Question 2. Which gas changes moist litmus paper from blue to red? Blue to red means it must be an acidic gas. So if we look at ammonia, we just did, it was an alkaline gas. It will turn red to blue. Hydrogen and oxygen both are neutral gases. So hydrogen chloride is the acidic gas, HCl. So if this gas dissolves in water, it forms hydrochloric acid. Now for question 3. Question 3 has two thinking processes. So let's read the question first. So when it says aqueous sodium hydroxide, warming, heated, so the first one, when we see warming with aqueous sodium hydroxide, we will ask ourselves, could it be again ammonium salt with base warming to form salt water ammonia gas? So first one, it could be this. Then when we read on and we see aluminium and everything else again, this would bring to mind the test for nitrate ion. So the second point is that this could be a test for nitrate ion. And if there is nitrate ion present in the white crystalline solid, then we should have ammonia gas. So if we have ammonia gas being produced, that means nitrate ion is present. So now we read on and it says that when we use a red litmus paper, it remains red, which means it didn't turn blue. So if the red litmus didn't turn blue, means there was no ammonia gas. So if there's no ammonia gas produced, for point number 2, we will know that there must be no nitrate ion in your X. And there must also not be any ammonium salt or ammonium ion in X. So when we look at the options A, B, C, D, they say which must be correct. So definitely X is not ammonium chloride. Definitely not. Okay, for the next question 4, as we go along, you will find that there is an error somewhere, but let's start with this. Okay, so the question 4 says, damn red litmus paper blue. So red litmus paper to blue means that this G must be alkaline. Okay, because what we are testing is the G solution. And the next one we are testing is the H solution. And it turned blue litmus to red. So which means H must be acidic. So here we are testing the solution, not any gas, the solution itself. So based on the litmus test, we can tell that it's alkaline and acidic. Now when we mix this together, so if G is alkaline, H is acidic, that means we are mixing an acid and an alkali. So when an acid reacts with an alkali, what you get is a salt and water. So if you look on, it does say that the salt is from simple salt. Okay, and next, we want to see what's in this salt. A salt will always have a cation and an anion. So when we use aqueous sodium hydroxide, it must be a test for cation. And we warm it. So in this case, we know it's a test for cation. And why would we warm it? It's because there is no precipitate seen. So when there's no PPT and we warm it, we are testing for the cation called ammonium, NH4+. So we're testing for this cation. And if this cation, ammonium ion, is present, what we would see is ammonia gas, which will then turn moist red litmus paper blue. So I write down what I expect to see if it is present. Then next you look at L, and L says there is a gas and it turns damp red litmus paper blue. So what does this mean? This means that the gas is ammonia. So if ammonia gas is produced, this means ammonium ion is present. So first we write L is ammonia gas so we can remember. Then we write that J, this salt, contains ammonium ion. Okay, so next we have the cation. We move on to the next part where they will test for the anion. And here they are using barium nitrate. So when you see barium, means that our test is for a anion. And this anion is sulfate ion. And if sulfate ion is present, what you will see is a white precipitate. And the name of this white precipitate will be barium sulfate, because barium sulfate is an insoluble salt. So if you look at K, K say there is a white precipitate, which means K is barium sulfate. So I'll write it down again. Okay, so now, since we know that K has barium sulfate, what ion does it contain? It should contain the sulfate ion. So here, this is the error. Okay, the error made by myself, I put it as a nitrate, wrong. The ion should be sulfate ion. So now we go back to G. If ammonium ion is present and G is alkaline, so ammonium what is an alkali? Ammonium hydroxide. So ammonium hydroxide is my alkali. Now if we look at what it contains, by right it should contain sulfate ion and it should be acidic. So by right H should be sulfuric acid. So this is the other error. We will correct it as we fill up the names. So first we fill up L is ammonia gas. This is correct. Next, K is barium sulfate. This is also correct because the sulfate ion is present. J, it's supposed to be ammonium sulfate. J is supposed to be ammonium sulfate. H, G and H. G is supposed to be here the order is different. So by right, H is supposed to be sulfuric acid and G is supposed to be ammonium hydroxide. Okay, so there's a few errors over here. So we move on to the next part before we correct all the errors. They ask you to form salt J. Okay, so this is where I realized there is an error made because the so because we're testing for sulfate ion, so by right J should contain sulfate ion. So this is me being careless. Okay, so answer for J is ammonium sulfate. So we go back and correct the correct one for H. H is sulfuric acid. H is sulfuric acid. Okay, so please make the change accordingly. So J is now ammonium sulfate. In fact, this order is not in order as well. So my G is supposed to be ammonium hydroxide. Okay, but anyway, I'm writing sulfuric acid here. So please switch H and G. Okay, so what we have is sulfuric acid as H, G, ammonium hydroxide. So please change that as well. And that is an error I notice now when I'm recording the voiceover. Okay, so now we go back to the chemical equation. Sulfuric acid plus ammonium hydroxide. So this is acid plus alkali gives you a salt and water. So the salt is ammonium sulfate and water. Now we write the chemical formulas. So sulfuric acid is H2SO4. Ammonium hydroxide is NH4OH. Ammonium sulfate. Ammonium ion is NH4 plus. Sulfate ion is SO4 2 minus. So we need more ammonium to balance it out. So these are the formulas. So this is a balanced chemical. We need to write a balanced chemical equation. So the first thing we do is we write the chemical equation. So this is where you must know your oh no so cold ne, the polyatomic ions very well. So once we write the chemical equation, the next step is to balance it out. So if you do your counting, you will need to put a 2 in front of ammonium hydroxide. And then if you count everything else, you will find that the hydrogen is not balanced. And you'll find at the left hand side, there is more hydrogen because of the number 2 in front of ammonium hydroxide. So if there are more hydrogen on the left, we need to add the hydrogen somewhere on the right. So if we count, we need to add water, H2O, we need to put a 2 there so we can balance out the hydrogen. Okay, so now that it's balanced, we left the state symbol. So acid must be aqueous, AQ, alkaline must be aqueous, AQ. Ammonium sulfate, all ammonium salts are soluble, AQ, water is L. Remember small letter L. Okay, now white precipitate K is barium sulfate. So barium sulfate, chemical formula. Ba2 plus SO4 2 minus. So barium sulfate, the chemical formula is BaSO4. Okay, so it's a precipitate means it must be solid state. And when we say ionic equation, there must be the ions present, and ions are present in aqueous solution. So to get barium sulfate, my ion must be Ba2 plus, sulfate must be SO42 minus, both AQ, and it's balanced. So therefore, this is the ionic equation. Okay, for question 5, we have nitric acid. So what is nitric acid? Nitric acid is hydrogen nitrate, which is HNO3 dissolved in water. You would recognize it better if we write the formula of nitric acid. So write the formula of nitric acid is HNO3 in aqueous solution. Aqueous means dissolved in water. So when we do distillation, what we are doing is we are getting our water because we are separating this mixture. So F would be water. Okay, next. Nitric acid neutralizes with metal oxide E. So when we talk about neutralizing, it must mean acid plus base reaction. So acid plus base, which is this nitric acid plus metal oxide, will give us a salt and water. So let's write it out. Nitric acid plus metal oxide. So my salt will be a metal nitrate. And I have water as a product as well. Okay, so acid plus base give me salt and water. So when this reaction takes place, what am I having is as a product is my metal nitrate and water. So when they say brown solution, my brown solution is the salt produced at the end of the reaction, which is metal nitrate. So I will write there metal nitrate. So how then do we proceed? If you look at the next part, it says sodium hydroxide. So this will remind you it is a cation test. So now we are trying to find out what metal could be inside this metal nitrate. So if we look at the color of the precipitate for a cation test, if there is any red-brown precipitate, means that iron 3 ion is present. So first we will write there Fe3 plus ion is present. Second, we will write the name of the precipitate. So this D is iron 3 hydroxide. Okay, so after doing this, we have figured out what is D. Now we move back up. If we know that is iron 3, and we look back upwards, our metal nitrate would then be iron 3 nitrate. And if I have iron 3 nitrate form, then my oxide will be iron 3 oxide. So E is iron 3 oxide. So when you write it systematically in this way, you are able to find the answers easier later. Okay, now when we look at the other side, you realize it's the same reaction where an acid react with a base to get a salt and water. So my salt here will also be a metal nitrate. And after that, I'm testing for aqueous sodium, using aqueous sodium hydroxide to test. And this would be a what test? A cation test. Which means that it could be a PPT, right? So it's a light blue PPT. It tells you that number 1, Cu2 plus ion is present. And number 2, the name of this precipitate, A, is copper 2 hydroxide. So we move backwards. If we have copper 2 hydroxide, our ion was copper 2 ion, so our nitrate will be copper 2 nitrate. So B is copper 2 nitrate. And if you move up, then C would be copper 2 oxide. because it is the presence of the Cu2 plus ion that gives you the changes. So once that is done, you can see there are many alphabets. So in this case, I will underline all the answers A, B, C, D at the bottom. Okay, we're going to underline D at the bottom, yes. D at the bottom. And then we'll underline E. And finally, we'll underline F. So this is to prevent the mistake that was made in the earlier question. And here in part A, thankfully, they organize A, B, C, D, E, F in order. So we just look up, track the answers for A, B, C, D, E, F, and we write them down accordingly. So if you notice by now, these QA questions that involve test for cation, test for anion, takes almost 6 marks just to guess their identity, and it takes another 2 to 4 marks to write a balanced chemical equation. So this one says for any reaction. So we're going to choose the one that we know best, which is the acid plus base give us salt and water. So acid plus base give us salt and water. And we're going to choose to do the one with copper 2 oxide because it's easier to get the chemical formula. So I always write the word equation down first so that I'm sure I do not miss out any products. Then once my word equation is done, I will find out what are the chemical formulas for each one. So by memory, nitric acid is HNO3. Copper 2 oxide, charges are balanced, so CuO. Copper 2 nitrate, charges are not balanced, you need more nitrate. And finally, water H2O. So now with the chemical formulas, you write it down. And then you check whether it's balanced. So to balance the hydrogen and the nitrate, we need to put a 2 in front. Okay, so now before you put state symbols, you read the question carefully. It says balanced chemical equation. It didn't say anything about writing state symbols, so do not write state symbols. If you may get penalized if you get it wrong.